exam. Exam start at that time. Okay, the lecture continues. Okay, so there's a new material.
Is this going to be an exam also?
As I said, the bus start for exam number 1 is the previous slide, the topic. So this is going to be on the next exam. Okay? So why people leave for some reason.
I have a lunch date with my son.
Oh, okay, that's important. Yeah, okay. Yeah, that's good reason. Okay. Now, on your exam number 2, this is the topic to begin. Okay. So acid and base, right? To remind you the definition. Being acidic is because of this species in solution, the H+. The actual species is hydrated, H+ dash water, H2O. So you end up with H3O+. Okay, then to remind you, strong acids, 100% ionized into cation and anion. So this is your acidic species. While for weak acids, will ionize just partially. Then how do we know the quantity, so-called partially, is based on calculation with the Ka, which is unique for the particular weak acid. Okay. Now, some additional background, freshman chem might not indicate clearly. Now, in order to make a solution acidic, you need at least 2 substances, not just one alone. HCl alone is a gas, right? So you don't get an acidic solution from HCl. So don't just look at the HCl formula, then you call that acid. It doesn't make sense. So you need 2 substances. Then you need the acid substance, which is a proton donor, so-called proton is the H+, the acidic species. And then you also need a base substance that is acceptor, so something to hold on to the proton. And therefore you end up with a solution. For example, the HCl substance, chemical substance, is a proton donor. Okay, it has H+ in the formula, so potentially it can donate the proton. Not as yet until it runs into a solvent. In this case, this solvent is a proton acceptor. It's going to accept it, and therefore it is a base. Okay, proton donor is acid. Proton acceptor is a base. So for chemical reaction now, the 2 combine, then the H+ will be donated and accepted by water. So now this is your solution, and this is acidic species, and this is your acidic solution. Okay. Now, how to define as conjugate acids as well as conjugate bases? So here, initially, you have an acid mixed with a base. So the base, you will see more definition how to define as a base versus the acid. But for now, let's use the symbol to represent the 2. So once they mix together, then proton transfer, then you get the B is acceptor. Why is called base? Because it can accept proton, right? So indeed, the B has accepted a proton become Hb plus. Okay, and the original acid now becomes A minus because its own proton has gone away. So now looking at this formula, is proton containing, then it's called acid, right? Then this one has no proton in it, it's called base. Then you may get confused, right? So this is acid, so what's the deal here? Well, to separate the two, the original acid is called acid. The one generated after reaction is called the conjugate acid. Okay, so now you know the difference between the two. Also notice the proton is associated with this chemical species, although it's called conjugate acid, it's not an acidic species after all, because the proton is intact, okay? So seems to be abstractive, but as we go on, it will be more clarifying. So this now is your base, different from the original, so it's called the conjugate base, okay? So now the pair, how do you pair up the two? Just simply look at the common anion to pair up the two. So the HA and the A minus, right, is your pair, your conjugate pair. Similarly, your B and the HB plus is your conjugate pair, okay? So this knowledge is basic for now, but it will be important later on for buffer solution. For example, now you have acid here, you have a base here. So now you end up with these two products. This is a conjugate acid, and this is a conjugate base. Okay? Yes.
For the acid plus base up there, you have a greater than sign. What is that for?
What do you mean greater?
You have that greater than sign. Acid base is greater than conjugate acid plus conjugate base.
Like an equilibrium.
Oh,
yeah,
okay.
right. Yeah. Yeah, later on, then we will talk about the polyprotic acid, then you will see a higher number of H. Okay.